In this video, let's look at a couple more examples where we need to determine if two triangles are similar by looking at their side lengths. And remember that with similar triangles, they have the same shape and the corresponding sides will be proportional to each other. Meaning, if we look at their ratio, if we look at the ratio of, let's say, the longest side in each of these triangles, then that ratio, that quotient, will be equal to some number, some proportionality constant. And if we then look at, let's say, the smaller sides of each triangle, their ratio, their quotient should be that same proportionality constant if the two triangles are similar. If it's a different number, then we know the two triangles are not similar. So effectively, we just need to compare the corresponding sides and carry out division. We can take this 10 and divide it by 9. We're comparing the long sides of each triangle. And if these two are similar, then this should be equal to the ratio of, let's say, the middle side divided by the middle side in this triangle. Or in other words, 9 divided by 8. And it should also be equal to the ratio of the small sides, or the quotient of the smaller sides in each triangle. We can take 6 and divide it by 5. But if you put all of these into a calculator, you will see that these are not equal. These are not equal to the same proportionality constant. We are not multiplying by the same number to go from the smaller triangle sides to the bigger triangle sides. It's different for each of these side lengths when we compare them. When we go to 6, starting at this smaller side of 5, we're multiplying by 1.2. But if we go from the middle side of the smaller one to the middle side of the bigger one, we are multiplying by 1.125. So it's not the same number that we're multiplying by to go from one side of the smaller triangle to its corresponding side in the bigger triangle. Or in other words, this triangle DEF is not similar to triangle ABC. And we can carry out the same method in triangle GHI. So let's do that. We want to compare the big side of triangle ABC to the big side of triangle GHI. We want to look at their ratio. We can take 10 and divide it by 8. And if you want, you can carry out the division along the way and simplify. This should be our proportionality constant if the two are similar. But if we take the middle side of triangle ABC and compare it to the middle side of this triangle, that would be 9 over 6. And you can see this is 1.5. So the fact that these are two different numbers tells us that choice letter B here is also not similar to our given triangle, which means in this case that neither of these triangles are similar to triangle ABC. So choice D would be the correct answer. And let's look at one more of these problems. But the main idea is that we want to compare the side lengths. We want to compare the corresponding sides and look at their ratio. So if we start with triangle ABC and compare it to EDF, then we can start with the long side in each. And let's look at the ratio of the bigger one to the smaller one, but you can do it in reverse. We can take 11 and divide it by 1.4. And if these two triangles are similar, then this would be equal to the ratio of the middle side in this triangle and the middle side in this triangle, which is 8. And we will divide that by 1. And we can also compare the smallest sides. So we have 5, and we'll compare that to 0.9. And for this, you might need a calculator, but if we actually carry out this division, what we get when we do 11 divided by 1.4, this is approximately 7.857, and it will start repeating at some point. And this, you can see, this is just 8. And 5 divided by 0.9 is 5.5 repeating. So the conclusion is that none of these are equal, which means these two triangles are not similar. the proportionality constants are not equal. When we go from, let's say, the middle side here to the middle side here, you can see we're multiplying by 8. But when we go from the long side here to the long side here, we're multiplying by this 7.857. And like I mentioned, it will start repeating at some point. But the fact that these are not the same number, we are not multiplying by the same number when going from one corresponding side to another, shows that these two triangles are not similar. And with that in mind, let's try choice letter B here. We can again compare the long sides. We can take the long side here, which is 21, and look at the ratio of that side to the long side here. Or we're essentially looking at the quotient of the two long sides. And if these are similar, then this will be equal to the ratio of the middle side here to the middle side here, which will be 15 for that one and 1 for that one. And likewise, if we look at the last sides, then, or the smallest sides, we have this 13.5, and we'll divide it by 0.9. And again, we'll need our calculator to simplify all of this. And when actually simplifying all of these quotients, we do, in fact, get 15, which means that these two triangles, triangle ABC and GHI, these are, in fact, similar triangles. They are proportional, or their side lengths are proportional. If we look at this long side, 1.4, to go to the long side of the bigger triangle, we multiply by 15. But that will be true when looking at the middle sides, going from 1 to, 15 over here, we are multiplying by 15, and going from 0.9 to 13.5, we are again multiplying by 15. And since we're multiplying by the same number when going from the smaller triangle to the bigger triangle, we can conclude that the bigger triangle is essentially just a scaled version of this smaller triangle. It is the exact same shape, though it's rotated. If we rotate it up this way, then it will be oriented the same way, but it doesn't matter. The main point is that the side lengths are proportional, which means that choice B is the correct answer. These are similar triangles.